So basically that for you. Now I just need an espresso machine. I love espressos. Wednesday. Looks like you just like beat up someone. The way you walked in.
Myself.
It's gonna be one.
Not me.
Hi.
Yeah, so it shows all of you. This time we will get to the level when we will operate several cameras and focusing on those who is speaking. If you want to, if he or she wants to be picked by the focus. Well, thanks for coming again. I am fearing that I will come to the empty class and it never happens, so I'm keeping me very happy. Thanks for coming. So, who we are and what are we doing? This is physical chemistry class. We want to describe reactions and characterization of chemical materials as an outstanding goal for our future. And with this deep motivation, we are realizing that there are no molecules without electrons, and electrons are most challenging part of molecules. They are light and vivid, like to move quicker, and therefore we focus on the principles and mathematical tools to describe how electrons behave in molecules, with possible future, not possible, definite future of predicting outcomes of experiments, or setting up, paving a way to predict outcomes of experiments. Right? It is what we are. Then we decided to go on a picnic in a figural saying. So we do have principles and some of mathematical tools, but we need to pick a simplest possible problem to analyze and to see that our tools work well or trustable, reasonably well. And we decided to look at the imaginary, fictional universe that has only one electron. Then you did. Can you please check that? Oh, everything's fine. I just on some of the equipment it was showing you that might, but it is not. So through discussion last time, we agreed, we collectively, constructively, cooperatively, creatively, we creatively selected the right scientific task that we can potentially solve with our mathematical tools. So we set up two hypothetical statements that probably would govern motion, evolution, behavior, properties of electron in the empty universe. One was rephrasing of Newton's first law, that if not perturbed, will keep the average velocity, right? And second one, we have hypothesized that if you squeeze electron in a localized form, but due to way the nature, it may decide that it wants to expand, or maybe contract, but definitely change the area of space where it protrudes to. And we set up this question in a more formal way as a find a width of the central Gaussian distribution of electron in space and see how does it change with time. And hypothesis is that if you expand, take more space. But now, that's it. The rest, about 2-3 lectures, where you, if you hate math, you can just fall asleep. Then after 3 hours, I said, yes, we have a wonderful, surprising result that it expands. So I'm just paving the way. But we are going through the a little bit boring and hard effort to support this hypothesis. I'm not expecting too much of enthusiasm because it is hard, but we will accumulate, we will develop some mathematical muscles, and later on the skills that we gain in attacking these simple problems will be helpful in something more complicated. And it will shorten our time that we invest into later investigation of more complicated problems. What else? Well, we were recalling all the tools that we can plug in, like 3 ways to predict future, expansion coefficients. For any, if we accept the 3rd way to predict future, we need to formulate the Hamiltonian, find eigenfunctions and eigen energies of stationary states for this Hamiltonian. And it looks like we already did it last time, right? Good. So what are the eigenfunctions called? Oh, what is the Hamiltonian of electron in free space? Do not give me like 5-star equations, just tell something simple.
Is that e to the negative I h?
You started to give 5-star equations. So it's kinetic energy, where momentum operator is replaced in terms of derivative over space, right? Something like this. What are the eigenstates of the Hamiltonian? We were not literally finding them, but we plugged in one of the test function and voila, it did work. So what was this test function?
A wave.
It was a wave, yes, correct. It was a which wave? Circular, cylindrical, elliptic, linear.
Plane.
Yes, perfect. Plane wave. So we have the one of the kinetic energy contributing to the Hamiltonian. We have plane wave as eigenstate, and we do have eigenenergies. How do they look like? If you have plane wave that has index k, which is same as momentum, like k times h will be momentum. So in terms of momentum, not operator, but eigenvalue of momentum, what is the energy of plane wave? It is not a provocative question. You do not need to study physical chemistry and quantum theory to answer this question. Same as classical mechanics kinetic energy of a particle in a free space.
mv squared over 2.
Yes, p square over 2m, and if we convert p into this k variable, it will be p sub k. Instead of p, we write h bar k, both of them squared. Right? So we have 2 out of 3 components to try the third way to try a third way to predict future in iron, in real life. And we are missing one component, the expansion coefficients. So we, again, creatively designed, because we are masters of our class, we do whatever we like. You can tell me, use different functions, and I will follow your order. we decided that if we prepare an electron localized in a specific area of space, it would be not a big thing to assume that it has a Gaussian distribution at times 0 as the initial condition, right? But now, in order to propagate it in time, we need first to convert this initial condition as function of position into form of expansion coefficients. So we from say this is a bad space. From psi of x0, which we assume to be minus x0. What? Square. We need to go to expansion coefficients, T sub k. And I'm not going to do it, because it is your homework. So in whatever, how many long days? All weekend, Monday, Tuesday, so on Wednesday, you bring and show that the expansion coefficients will look like square root sigma 0, which is the same as here, constant pi, e to the minus sigma 0 k squared over 4, something like this. I cannot brag of strongest mind on the globe, and I can mix something constant. So we take it as an input. It is what we start with. What else is on our radar? What are we doing? What are we planning to do? So we will plug all components. As majority of you are chemists, you typically do reactions. Just measure amounts of reactants, put them in a container, mix, heat, and then get products. Here, the experiment is more, well, we keep chemistry in mind, but it looks like mathematical experiment. We have component, formula 1, formula 2, formula 3, mix together, stir, maybe integrate, and then get the answer. Same ideology, right? Components, product. Did any of you looked on the homework, how it is formulated? Do you find it challenging, or it is like 5 minutes? Not 5 minutes. Well, I have an idea that we arrange today's meeting as a twofold purpose. On one hand, it will help general class material. On another hand, I will use and show tricks, that shortcuts that help to solve exactly the same type of problem as you do in a homework. So if you follow manipulations that we will do on the board, you just repeat them at home. And well, if you're confident, if you know what you're doing, it can be done within like 40 minutes. But if there are attempts and failures, it can expand up to a couple of hours. But do not expect it to be done in 5 minutes. If you spend 5 minutes and haven't got the answer, do not panic. It's normal. I think it is enough. And on Wednesdays we will. So what are we doing on Wednesday nights? We are preparing tools, instruments, and skills that will help us to avoid boring and challenging math. So we will go through some software that will allow to get to answers of some problems without deriving equations, basically. Okay, almost 15 minutes left, and I am yet on the very end. So it is where we did set up the width me expand. Okay, a little note. What is the expected answer from your homework? How do we interpret it? So I'm sure you'll do it. You'll be a successful completion. But from scientific point of view, what do these coefficients mean? Are they just boring mathematical components, byproducts, or they have any value in that? So again, mathematically, it is expansion coefficient of our initial state over plane waves. Plane waves meaning waves that have different momentum, different velocity. So if we have non-zero value of ck for given value of momentum, it means we have a substantial fraction of momentum of plane wave with given momentum in this superposition, in this initial condition. It means we compose our localized wave packet as several waves, each of which moves with its own velocity, its own momentum. And this c sub k is fraction of a wave with wave number k, or with momentum h bar times k. Try to reformulate it in your own words and make some comment. You probably can do it better than I. So, in some sense, if you have these expansion coefficients, then you do not need the wave function. They are mutually replaceable. It's like different implementations, different glance, different ways to store this information. And since this k is the same as momentum, we can call this expansion coefficients as wave function in the momentum space. Like typically we live and our intuitive thinking goes in coordinate space, where like space means point 1, point 2, point 3 that we can touch, coordinates. And here we have a range of different velocity, different momentum. And there are no mathematical laws that forbid us to think abstractly in this space of different values of momentum. Okay? So conversion between true space, coordinate space, and momentum space is by integration by this plane wave is nothing but what? It's question number 0, or first line of question number 1 in the homework. So if you have this integral times exponential and some function.
Fourier transform?
Yes, it is either Fourier transform, and some people make and call it Laplace transform. Fourier transform. So the shortcut, if you do not want to do homework, that you want to get the answer, you just look online for Fourier transform of Gaussian function and play with coefficients. So we, fortunately or unfortunately, we are not the first in the history of human civilization who take Fourier transform of Gaussian function. It's pretty popular, it has been taken many times, and it has dissolved into internet and to some tables of integrals. So it is not very big novelty for human civilization. It could be novelty and good exercise for us, but any ways where you get solution and answer and the way how to get solution is legitimate. So if you're skilled in browsing through internet and finding the right answers, it's your power use. Okay. Good. A function in momentum space. And now we do have our prescription, our protocol, how to predict future. So we take this expansion coefficient, we take the energies, eigenenergies, we take the eigenfunctions and add them together. So due to phase accumulation that is different, I probably want to expand it so that you see it. I don't know if any of you need and use the recordings, but just in case you can follow, especially when it gets the homework. Right. So there is a phase accumulation which is different for each term in the sum, and due to this phase accumulation, we are propagating from time 0 to time bigger than 0. So that's enough for us to know scientifically, but unfortunately we need to perform this summation. Well, here we can put square root I square root sigma 0 minus k square sigma 0. So we populate the boxes, take summation. Yes. Now, everything we are doing here can be squeezed in 3 minutes, but then probably we will not concentrate on important points. So I'm trying to elongate it and chew on each specific point so that we feel more comfortable and there are no surprises, that we see the logical continuation, logical line of narration. So we need to perform summation. How many terms are present in this summation? Yes. And what is the spacing between different values of momentum? Infinitely small. So if we take...
Hey, you have one. That's okay.
When I was on the 3rd year undergraduate, I was attending maybe 50% of classes. And I'm so surprised that you are much better than us. Summation of infinite number of terms with grid points are spaced infinitely close. What does it look like?
There you go.
Yes. Oh, it's probably true. So we take the expression from previous slide, our prescription for predicting future, and just replace summation by integral and add the infinitesimal increment of this momentum. Good? Now, surprise please. Do not be scared. You are welcome to use your notes. It is mostly for me to assess my instruction, like if I communicate well and you're getting an idea what we are doing. Write your name and fill boxes. let me know who is done by lifting hand or camera cover. So the idea is to put not symbolic but exact expressions for energy, function, and expansion coefficient. Please attract my attention if you consider things that thing is done. I'm just curious who will be the first. Okay? Okay, first thing is brought in and awarded with a license to MATLAB software. Who is the second? Second. No? It's almost time to collect. Who's brave to declare completion? Okay. Yep, thank you. Second from the first is also awarded with MATLAB license. And there is one more award with the third. Okay, Mark. Congratulations with being quick thinker and quick writer. Okay, now it is time to collect the rest of works. Okay, so how would I do it myself? Well, eigenfunction is e to the power I kx, right? More than half of you place in this way. Some of you put general expression phi of x sub k, which is not wrong, but it is, I will make a joke. Write a Newton's law. It's a real history from, sure, I can write a Newton's law. So formula correct, right? So with more specifics is better. Now eigenenergy, it is what we got just a minute ago. H bar square p square over 2m. Or instead we can write h bar square here. Or instead we can do k. I'm not giving good grade to myself. K k squared 2 m h bar squared. Yes. So eigenenergy. And expansion coefficient is expected answer from your homework. Square root pi, square root initial width of your wave packet, and then some exponential of minus k squared times sigma naught divided by 4. It is end of physics and chemistry for the day, and start of math. We have to take this integral. Right? And it is a major challenge for me now, for you now, and for you during the weekend. Because your homework, question number 3, will be an exercise to take integral of the same mathematical shape. The arrangements of coefficients will be slightly different, like you may have plus instead of minus, you may have a little different coefficients in this exponential, but it will be very, very similar. So the tricks that we do now will be applicable to what you do in the homework. Oh, by the way, color. See, here is h squared, and here is h. You can cancel it and have h to the power 1 there. Function, phase accumulation, expansion coefficient. So any suggestions how to take this integral? It would be not a big wonder if some of you suggest right away. You may have taken integrals like this in the past. If not, it's not a problem. I'm prepared.
Can you merge the two e's?
Huh?
Can you merge the two e's? Would that make it easier?
Or should you just point my finger?
The two e's that your finger are at right now.
Oh yeah, yeah. One can merge these two e's and put it as an argument. Yes. Exponentials. To exponential is this complicated polynomial in the power. So our integration variable is k, right? And here, actually, you can merge it even with the third. And in the power, as an argument of exponential, we have a function of k, of our integration variable. So which maximal power of this polynomial is here?
2.
2. So we have k and k squared. So we need to know how to take integrals of this type. So if you know answer to this problem, then we can just tweak coefficients, make some transformations, and convert this integral into such form. We will see it, if time allows today, if not at the very beginning of Monday. But what is the answer of such integral? If you do not know, I am so happy then I have a chance to tell it to you. So it is, well, it is important part of higher education. This integral is maybe the only one that is generally applicable to very broad areas of knowledge, including those areas of knowledge that are very far from science, like data analysis and business, accounting, statistics, any areas. Not recalling or not having ideas? Well, the e to the power minus k squared, this is our k vector, it will be same Gaussian shape. We integrate from minus infinity to plus infinity, right? Integral is summation over this area. So will it be very big or very small number or something reasonable? So since it is not infinite, it is finite width shape. If we do not specify width, it will be like 1. And the height is also about 1. So it is very similar to just square box of width equal 1 and height equal 1. And the answer should be around 1. Right? So if you are in hectic rush, you can replace answer of this integral to 1. And it will be maybe off by like 3, 4, 5 times, but generally it will be correct. You will not violate any big signs. You will be correct by the order of magnitude. It's my favorite thing. In math, although I hate it. I hate math in general, but not in here. So here is the trick. You need to take integral of one Gaussian function. Let's call independent variable whatever k or maybe x. So here is the very unusual out-of-box thinking. If you need to take one integral, why don't we take 2? So let's formulate the same integral of different variable, like y. Okay? Now, what if we know that answers will be the same, because it is just integration variable? And it will be nothing wrong if we multiply these two integrals by each other, and then later we will take a square root. First, second. Okay? You're with me, you're not objecting. You'll like it, I promise. If you have a little part of your soul not terribly against math, you will like this chapter, this section. Your suggestion: 2 exponentials can be considered as one exponential with summation of arguments. Following your ideas. Your word is my word. X squared plus y squared. If we are thinking about geometry, 2-dimensional space, what is xy plus y squared? X squared plus y squared. Do not hesitate, you know it.
Circle.
And the x squared plus y squared will be radius of this circle. Right? Good? What is dx times dy? Geometrically. Forget algebra, forget calculus, think geometrically. So d.
An infinitely small area.
Yes, infinitely small area. So we need to add together, we split the space on these little squares, and we add together areas of this infinitely small elements of area multiplied by function, which looks this way. So the function will be maximal in the center and will decrease away from here. So it's like a Mexican national hat, sombrero. Okay. Sombrero. It is not symmetric. Rectangular coordinates are not always appetizing. So you may want to convert into the which coordinates? Polar, yes. So what is the element of area in the polar coordinates, where we specify, instead of rectangular blocks, we have this segment specified by angle d phi, and we have the infinitesimal increment of radius. So how do we express this element of area in the polar coordinates?
R dr d theta.
Why?
Well, why?
Yes.
Because I used to know. I lost it.
Well, I was trying to convince myself that if the area is distance squared, derivative of distance squared will be proportional to first order, but then the increment of the area will be RDI. I don't know if you buy it, but you can spend more time on the writing when you want. But this is a legitimate area of such segment. Let's take it for now so that we do not waste too much time, which is running out. So I'm asking you to believe in this. Now, our integral square will be formulated as the function times element of area, right? And here we integrate over radius and over angle. For radius, we go from 0 to infinity. For angle, we make one full circle from 0 to 2 pi. 2 pi, just. I should be able to take this integral. Do not give me answer. I want to do it myself. So pi squared integral from 0 to infinity dr from 0 to 2 pi d phi e minus r squared r. Right? So let's take first integral over angle. The function doesn't depend on angle, right? So it is independent variable. We can put it in a box. Integral of unit function d phi from 0 to 2 pi. Correct? So integral of 1 will be phi, and then we need to change it from, explore it at values from 0 to 2 pi. So the answer will be how much? 2 pi. Yes. 2 pi. 2 pi. And then the rest is integral from 0 to infinity r dr e minus r squared. How do I take this integral? How do we take integrals in general? What is the rule? Well, you have several tricks from calculus, but one of them is to place, submerge, dive, insert function and under the symbol of differentiation. To have, like, can we put this one under D symbol and pay some price for it? 2 pi integral 0 infinity. So r times dr can be passed as d over r squared over 2, right? If you take derivative of r squared, we get 2r and cancel this 2. d r squared over 2. So this 2 cancels with this 2, and here we have minus r squared. Good? I don't like r squared. It's too complicated for me. Can I replace letter symbol r squared to letter u as new variable? No one forbids. So then it will be integral by upfront from 0 to infinity du times e minus u. I want to solve problems only on this level of complexity. I don't want to do anything more complex. So what is integral of exponential?
Negative exponential.
Yeah, but in simple word, if a stranger in store catches you and asks, what is the integral of exponential? You will not give the answer. It's like exponential again, right? Okay. And exponential, right? Exponential, and then we explore it at which limits? From 0 to infinity, right? What is exponential of infinity? If the power is negative. So e to the power minus infinity equals
1.
how much?
1.
Another try?
No.
Much better. So
Gotcha.
exponential decrease, e minus u, and gets to 0. And what is exponential of 0?
1.
Yes. So we subtract 0, and the 1 comes up front because we have different sign in this differential and in the power of exponential. So minus pi times minus 1. What will be the answer? Pi. So the area under Mexican sombrero equals pi. Mathematical law. Now, but it was trick. We found I squared, but we need I. Right? So what will be the answer for I?
Square root of pi.
Yes! Perfect. You are accomplished mathematicians from now on. Most of problems of modern math can be reduced to this problem. It's substantial part. So integral of Gaussian function can be cast as pi, square root of pi. Okay, I'm not sure if you have time to complete everything, but we will start. So now our reaction, our mathematical experiment is almost done. And you are almost prepared to do your homework. So we know the answer for Gaussian integral. And you see that here is the boring list of polynomial of second power, right? If you start, mathematical derivations is repeating almost the same expression again and again, practicing of calligraphy. That takes most of the time. If we keep all these notations, it's correct, but spending most of your time. Why don't we set up a dictionary? To simplify this notation to such extent that we can quickly write again one step, another step, get answer, and then translate our short answer back into this long form. So we want to go from long to short. You can take notes because there will be nothing else. We already have the answer. The answer of any integral of e to the power minus second power of independent variable square root of pi. You'll get just some constants. And we need to convert our expression to this form. It's like boring, dirty work. And the thing to simplify it is through such not very intellectual tricks. Make it shorter. So we can call this everything except k. So minus I times x will be a constant. Everything except k squared here. So this ah bar over 2m times t will be b constant. If, and we need also to add this minus initial width. You do not see it. I blocked it here. But you have the definition here. So you put this thing plus whatever was contributed from the initial condition. So you replace long integral by this short form, where shorthand notations A, B, and C defined this way. You can do it similar way in your homework. The definitions will be different, but in fact you need to take integral of this form. Now, how much does it differ from the integral that we know how to take, from the simple e to the minus k squared dk? Does it differ much? How can we bring this expression into this form? We can convert this expression into some new variable that will be, I don't know.
Or they can factor it and then just instead of k squared minus bk, then change it into some other constant.
Do you hear? Can you repeat once again?
You factor it into two equal factors and then make that, or just put those together for squared.
Yes, 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 it's an excellent plan. I was thinking similar way. So we need to convert E. If you need to go to next meeting, you're free to leave. I will not give any new signs, but I think it is, we have 11:50. I just, for those who are curious, I will tell a couple of words more, but it is not mandatory. We will continue, so you're free to leave. We'll continue on Monday. It's just a little bit of words that may help towards your homework. So the idea about factorization, we can identify this polynomial, find that it may have a form of full square, and then this full square will be a new variable. Okay? But here we do have only two terms. And for full square we need 3. So where do we get the third term? We can always add and subtract. Okay? So this is the same a times k squared, but we can replace it as new variable squared, right? Then in the terms of these variables, we can cast our second term, which is linear in k, as by multiplying and dividing by the same factor, we will identify the variable a here, and then the rest will be variable b. Okay? And then the next step is to add and subtract such thing that is missing here for identifying a full square. So we add this b over a and subtract. So if you do it this way, then we are having integral dk e to the power minus a squared plus 2ab plus b squared times e plus b squared, right? And this thing can be identified into new variable, and this will be our price for doing this tree.
So that's your subtraction.
Yes, it is my subtraction. Well, addition. It is sign plus and sign minus comes here.
Okay.
This little b
Gotcha.
does not depend on k. So it is not a function of k. Therefore, we are not going to integrate to use it for integration. We can place it just up front and then take integral only on whatever is here. Good. So we identify full square. Then we can change a little bit this k variable to match whatever needs to be done. And then this part, with very simple manipulations, can be converted into square root of pi. Any one of us can do it. It's just boring 2 extra minutes. And then it is pi times this price factor. So the answer, basically this price factor is the meat, is what gives us the important thing. And if we plug into this simple answer our dictionary, then we will get something that is interesting to analyze from a scientific point of view. So if you follow the same idea, the same protocol for your homework, if no errors, if you're careful, I promise 40 minutes and you're done. Well, if it is a sequence of failures, you will repeat this 40-minute line a couple of times. But it is doable. And thank you for staying longer than needed. It's my favorite side. Meeting is finally complete. Have a nice weekend and see you on Monday.